Hey everyone, welcome to the Customer Success webinar series. This is our third session. I'm Scott Slamba, the head of Customer Success here at Komprise, and with me is Paul Chen, head of Product Management. And this week we have a special guest. We have Benjamin Henry, who heads up our Storage Architect team. Quick reminder on this webinar series is this series is geared towards existing customers, and we're just reaching out to some of the major enhancements that came to the product over the last year or so, advanced use cases, best practices, all that. It's not a marketing pitch, it's not a sales pitch. It's just a nuts and bolts conversation of things that you can do with your product now out of the box to make the most out of your subscription. So today we're going to talk about performance. So Paul's going to touch upon some of the performance enhancements we've done with Komprise under the hood. And then we brought Ben on because what he's going to do is he's going to talk about performance best practices in general. And the thing to keep in mind is that Komprise is a software platform that sits on top of other infrastructure, namely operating systems, file systems, virtual machines, networking, et cetera, et cetera. So if any of those elements are not performing at its best, that could implicate the performance of Komprise. So basically, Ben's going to walk through a lot of the trials and tribulations he's gone through in the past year or so with deployments and best practices for performance. Quick reminder on some logistics. If you haven't figured out, on the upper right-hand corner, there's a square symbol that puts you into full screen mode, so that would give you a better experience. We do want to keep this interactive. This is an informal, interactive presentation. It's just really informative for you. So we do encourage you to ask questions. On this platform, you're not going to be able to ask questions audibly. You need to ask them through the chat. So on the right-hand side, you should see a question mark button, and that's where you can ask your questions. Paul and myself will be monitoring that box throughout the webinar. This is a 30-minute webinar. Depending on the conversation that develops, we might go long. I think last time we were right on time. The time before we went a little long. We had a lot of good dialogue with questions. A couple other logistics that's not on here. If you look at the paperclip button on the right-hand side, there's some links to some other artifacts that we've posted. And then finally, if you missed the previous sessions, or if you want to have someone else look at these sessions, we have recordings to all the early webinars. And to get there, you just go to the registration site. You get links to the early recordings. If you lost where that registration site is really easily, you can just go to the support portal on the homepage under announcements, and it'll point you there. And I believe on the paperclip, the bottom link there, it actually does point you to the Freshdesk portal. So with that, the agenda. So I just kind of explain what's going on. So Paul's going to talk about performance updates, and Ben's going to pretty much take over from there, talking about best practices. So with that, I'm going to turn it over to Paul.
Whoops. Very good. Thank you, Scott. As Scott mentioned, Ben is the star speaker today. He's going to talk about a lot of best practices for managing performance with Komprise. What I wanted to spend a minute or two talking about is just to make sure everybody knows Komprise provides a lot of capabilities and features. And when we talk with customers, they always ask us, can it do X? Will it do Y? I'd like it to do Z. Very feature sort of mindset. But the underlying number one requirement that people just assume or expect to be there is performance. And we have found in direct customer engagements, if we can perform exceedingly well, that gives customers the greatest benefit, because most of the time when they decide they need to mobilize data, unfortunately, it's on a very short time frame. And the faster we can do it, the better we help them achieve their goals. So I just wanted to give a quick review of some of the major performance features that we've put into the product. Performance is in the DNA of the product. Everything we design, when we add new capability, we always do performance optimization as part of the standard development and regression testing. So I'm only calling out here some of the major things that we've done. And you'll notice I put version numbers for some of these features only to show you that we have been working on performance from the very early outset of the product back to version 2.x. We're now on currently version 4.6, and you'll see throughout the development cycle of the different versions and releases, we do make performance improvements continually. The top section there mentions plan. This is for our plan archiving, the move and copy operations. These are, we found, a little bit less sensitive to performance because when customers are archiving, they know they're doing it on a very periodic basis. Every week, Komprise is going in, looking for cold data or data that matches their archive policy, and then archiving that data away. On occasion, we do have customers who need to archive something very urgently in order to free space. So performance is still, of course, important. And we built something under the covers that we call the batch transfer engine. For each file that we transfer, there is some overhead. We have to read the file, we have to get the attributes, we have to copy the attributes. That per file overhead becomes significant for small files, because for small files, the actual copying time is short. So for small files, we are paying a high price per file to do any kind of data mobilization, data transfer. So we created what we call a batch transfer engine that essentially just batches up multiple sets of files and their metadata and does a single transfer that way. And we were seeing 6 to 8x improvement for small files. It does help for medium and larger size files because, of course, batching will help in general. But of course, the larger the file, the more time you're spending actually copying, and the less proportion is actually copying metadata or something like that. We built it initially for NFSv3. We added SMB later. Move and copy now perform very, very quickly. Then we turned our attention to migration. Migration actually turns out to be more performance sensitive than archiving, because when an organization decides they need to migrate data off an old piece of hardware or want to migrate to a different platform, unfortunately, it's usually on a very tight time schedule with very tight cutover times. They can't disrupt users, etc. So performance on migration is key. Back in the 2.x timeframe, we improved our performance by doing no checkpointing crawls. So as we're going through the file systems, looking for files to copy and migrate over, we were setting checkpoints. So in case you want to pause the migration, or if an observer goes down, we would pick up from where we started. Turns out the checkpoints didn't actually bias very much in terms of resumability, but it does cost us quite a bit in performance. So we were seeing 1.5 to 2x improvement just by not doing checkpoints. So that went in quite early. Then we created something we call Elastic Data Migration, which leverages multiple observers and proxies to parallelize migrations, as well as creating our own client protocol for NFSv3. We call that KCP, Komprise Client Protocol for NFSv3. And there we were getting 5x performance improvement. So huge for NFSv3. We're now working on a similar KCP for SMB and hoping to see similar improvement. In the meantime, we were able to improve the second and subsequent iterations for SMB up to 15x, huge performance gains for those subsequent iterations. Just what I mean by that, the first iteration of any migration is always a full copy. We see everything, we copy it over to the destination. These are live file systems, though, so we have to do subsequent iterations to make sure we catch all the changes. Here, we're scanning those file systems periodically, looking for the changed files, and that scanning can take time. So really, the copying is less significant in the performance time. It's more of finding the files to copy, and we improve that with a different algorithm in a recent release, 4.5. So again, just a brief highlight of some of the major improvements we've done. We're always continually looking at performance. Be assured that it is our unspoken number one performance requirement, and we're continually looking at ways to improve it. And I'll turn it over then to Benjamin.
Awesome, thanks, Paul. So to kind of set the stage, before we even get into the migration scenario, I'm going to talk about topology for a minute. So topology is a lot like a roadway. And the road could be a unmaintained winter dirt road. It could be a 10-lane superhighway. The difference being that the amount of data you can move, or the amount of cars you can move down that highway, will vary greatly. So for example, if you have a tractor trailer, and let's say the tractor trailer represents your data in a migration. If you try to send that tractor trailer down an unmaintained dirt road, it might get to the other side. It might not. It might break things in the process. Whereas if you send that tractor trailer down a 10-lane superhighway, it might get there quickly, but you also want to consider what lane that tractor trailer is in. Is it in the far right-hand lane? Is it subject to merging traffic? Is it subject to slowdowns, accidents? So those are some of the things you kind of want to put in the back of your mind when we talk about migrations and topology. So let's set the stage with a typical migration scenario where you're presented with 750 terabytes of NAS on end of service life hardware. So it's out of warranty. There's no remanufactured parts. The vendor has said we're no longer dealing with this technology, or it was sold, or they went out of business. Consider you also have an active hardware fault. Maybe there's a power supply that's faulty, but it's stable, or there's a network card that's faulty, but you have redundant ones. So set the stage that the conditions might not be best, but your job is to get the data off of that as efficiently as possible. Leadership has approved a 30-day period to prepare for the migrations and also a 48-hour outage for the cutover. Also consider that maybe teams have isolated this piece of hardware because it's legacy, it's older, it's unmaintained, hasn't been patched. And also consider that your new NAS is ready to go. So what do most people think when they're in this scenario? Okay, my old NAS is on the left-hand side, my new NAS is on the right-hand side, draw a string between them. Let's just send the data across the wire and we'll get there. Let's go back to that topology scenario. So if you send a single car down a dirt road, it'll probably get to the other side, no issues. Tractor trailer, one tractor trailer might make it down that road. If you send 100, 50, 1,000 tractor trailers down that road, you might start to see some fractures in the environment. So again, most think when a migration, old NAS, new NAS, draw a string between, get the data there, no worries. However, this might actually be the environment you're working with. It's not just a single string connecting the two. You're going to have your old NAS on the left-hand side, new NAS on the right-hand side. There might be gateways, routers, firewalls, and then repeat on the other side. So why is this a concern? Well, every time you have another appliance, another firewall, another security device in that way, it's going to create a slowdown. It's a toll booth. So if we're even on a 10-lane superhighway, so let's talk about the left-hand side, right-hand side. Let's just say everything, all the NAS is 10 gig connected. Cool, that's awesome. But then we hit the gateway. Then we hit the router. All right, well, now there's a 2-millisecond delay. Then we hit the firewall, 15-millisecond delay. The router on the other side was undersized, maybe. Another 5-millisecond delay. Hit the other gateway, 1-millisecond delay. Now you're at the NAS. Every time you go through those toll booths, you have to pay your toll. In this scenario, it's time. It could even be a little bit more difficult than this. And let's just say that the left-hand side, 10 gig, right-hand side, 10 gig. But as you get closer and closer to what's bridging these two networks together, this firewall, someone may have repurposed an old firewall. And you know that your NAS is 10 gig connected because you've logged in SSH through the UI, whatever it is. It says, I'm 10 gig connected. Well, what if no one told you this firewall in the center, left-hand side, right-hand side, only has 500 megabits of throughput? And oh, by the way, at any given time, it has 300 to 400 megabits of constant utilization. That's going to significantly impact performance when it comes to migrations. So what can you do as a quick way to overcome some of these tolls? Well, as I talked about earlier, you're on the 10-lane superhighway, get in the express lane. So one of the quickest ways to get in the express lane in this situation is to implement something known as whitelisting. So if you know your source data, you know your destination data, source and target, okay, it's known data. Work with the network teams, work with security teams, implement a bypass process. Maybe you still have to go through all these appliances, but you won't be subject to the same scrutiny as other data. Sometimes you may be able to go around these appliances. Sometimes you might be lucky enough to do a switch to switch because maybe your switch is also the gateway, so you can do a temporary cable around it. This is one of the biggest issues I see day in and day out when I get called in. Hey, I'm having a performance issue. My migration's slow. My data seems to be stalled. Well, back here in this process, if we have any of these appliances that are underperforming, there's a good chance you're going to have network drops, retries, and retransmits. And when you're starting to send data in high volumes, now the issue is compounded even more. So where you might send one file, one folder, one share, you might not see the issue. But then you start sending all those tractor trailers of data across the wire is when you start to see the fractures. So consider working and partnering. It's a team. Migrations are not just done in a silo. Successful migrations are done together with other peers in your organization. Definitely talk with your network teams, talk with your security teams before you even go and approach a migration, because you want to know, what does your topology look like? Do you have a single lane highway? Do you have a 10-lane highway? Is it a clear path? Is there an option to use an express route? What do you have that can improve efficiency and not bog other processes down? The last thing you want to do is start a migration and actually have this firewall start shutting down and impact other traffic as well. So in addition to topology, some of the other things that I see within the path are, like we talked about, bandwidth concerns, latency, intrusion detection, intrusion prevention systems, firewalls. And another big one I haven't really touched on yet is antivirus. It's surprisingly or not, it's one of another, probably the second issue I see most frequently is antivirus is turned on either on the source NAS, on the target NAS, or on a server that's involved in the migration in that path. And again, just like whitelisting, consider the traffic. So you know the source, you know the target. Is it really required? If it is, make sure you consider scaling up the antivirus agents or the number of servers in that process. So if you're scanning on the source, maybe you're only doing reads in that process for your migration, so you can turn off scan on read, only scan on writes. That way your clients are still protected. On the other side, if it's not a production NAS yet, do you need antivirus running there at the same time? Do you need it running on the servers during the migration? So just food for thought, some considerations in that process. And then I always make a plug for this: test, test, test. You cannot test enough. And some of the biggest, some of the easiest ways to test without involving a lot of tools is just a simple ping. Can you ping from source to target? What does your response time look like? What's your latency? You're going to find that out just through a simple ping test. Beyond that, do an NS lookup. When you do an NS lookup, you're going to see all the hops your data is taking in that process. And then you play the game of, what is this? If anybody's had a small child, they always ask, what is this? What is this? What is this? Use that to your advantage. Ask your peers, ask other team members, what is this? If you don't recognize that IP address in the hop, then ask. And ask, is it even relevant? Do we need that, or is there a way to bypass that? Is there an express lane that we can use there? iPerf, another excellent tool, and Wireshark. Wireshark is one of those tools when someone says, I'm going to install this and take a look to see what's going on, everyone can kind of get a little nervous. So honestly, all you need Wireshark for is to just check for network drops, retries, and retransmits. If you're starting to see those, then there's a potential bottleneck in your data path, in your topology.
Hey Ben.
Yeah.
Before you move on, I'm not sure if I don't think you're going to go there or not, but can you talk a little bit about virtual machines?
Oh, sure. Yeah, absolutely.
Yeah, because
yes. So there can also be a number of factors when you work within a virtualized environment, and the biggest indication of something brewing is CPU ready waits. If you don't have enough physical resources available for the VMs in that environment, you can experience ready wait, which is a condition where the VM guest is saying, hey, I have something to do, but I need 4 cores and 8 gigs of memory. And the hypervisor, the physical server, is saying, wait. Well, that wait is CPU ready wait. It's saying, I don't have enough physical cores, I don't have enough memory to get that VM image in to process its request and then move on to the next server. Another common issue that we see is where you have high ready waits, and then you have migrations taking forever because you can never get the resources you need to actually perform that migration. You could also have DRS enabled. DRS is another culprit, where when you start moving VMware around automatically, you could have a VM on an ESX hypervisor node 1, and it's saying, okay, I'm happy, but then a large image comes in, and now you're in a ready wait condition, but VMware can be configured to say, okay, in that condition, move the VM to ESX hypervisor 2 or 3 or 4. If you have an extremely busy environment and you have an aggressive DRS plan enabled, you could constantly be moving VMs around the environment, which in some cases, some applications work well with that because it's a lot of processing behind the scenes. But if you have any network heavy applications, DRS is still physically moving the network ports every time it moves between the ESX hypervisors. So that's like walking up behind the physical server and pulling out all the network cables every time it hops between physical hosts. So one of the areas in best practices is any network heavy or network intensive application, it's a great idea to set DRS to either off or to manual for those VMs so that it's not constantly being pivoted around, losing and dropping packets as you're performing a migration. Scott, are there any other questions you want to ask on that?
Well, I guess more of a comment. So, a couple common scenarios is we'll have a customer doing a POC before they actually go to production, right? They'll do that in the pre-sale side of things, and they'll size the grid, the number of virtual machines and the resources each machine has for that POC. And then what happens is at a later date, customer may go with the product and they decide to go to production, and quite often they'll leverage the POC grid that they deployed earlier. But what they might not do is go back and revisit the sizing of everything. So, going from a POC, which is usually a contained, smaller use case, to a production that's going to be much bigger. A lot of times, we end up using the same VMs and we don't scale up or scale out or whatever. Another common scenario is, maybe the initial use case might be analysis, and then we might move on to starting to do some tiering. Well, that takes up a certain number of cycles, CPU cycles. But then when you go to a migration, which is a much more intensive operation, you may need more resources as well to meet your cutover windows and whatnot. So, and I just want to kind of lay that out there. Is that it's a common thing you see is the over time, as you go from one use case to another, the needs of that underlying grid may change, and that could heavily impact performance. And it's a good idea to revisit that every time you do that.
Well, that's a great segue into the next slide, Scott. When we talk about something called ACE, Assessment of Customer Environment. This is something that Komprise does offer current customers, which is where we will do a number of things. One is we will look at your current environment. We will want to understand your current objectives. Have they changed from your original objectives, or are they still the same? Are you sized appropriately? We'll take a look at your workloads that are in play right now versus what you're planning in the future. We'll look at the VM resources. We'll look at the number of proxy servers, the number of observers. We'll see how busy they are, the number of threads you have running. Are you doing migrations and archiving? Are you just doing analytics? That will be taken into consideration. And beyond that, we'll also want to start looking at topology. So we have an application that we will run behind the scenes that will test throughput from several different sources and targets. We can go with on-prem NAS, we can go with cloud NAS, we can go with Azure files, we're compatible with S3 targets. So we'll test throughput there through a series of sequences, and we'll also test not just the performance of those files, but we'll also look at the ability to move permissions around, as well as checksums. How long do they take to compute in the process? Because no one wants to move data and not have it validated if you're subject to regulations. Regulations are something we really haven't touched on here, but we'll touch on a little bit more in our next webinar. But you might be in a validated environment or a regulated environment that says, prove to me when you moved your data that it's still the same piece of data from point A to point B. So we're going to look at those, and we're going to evaluate the timings behind each one of those processes to help you understand, do you have any bottlenecks before you even begin? If you're in a situation where you're seeing slow performance, by all means, please reach out to support, reach out to your customer success manager, reach out to your account team. Let's get one of these scheduled, whether it's the full-blown assessment or just the performance tuning. We're open to any of those processes. With that, Scott, any more questions?
Hey, Benjamin, I had a quick question on that. So this ACE product and service that you're mentioning, just to be clear, this is separate from the Komprise Intelligent Data Management. Is that correct?
Yeah, that's actually a great question. So it is separate. So one of the things we want to do is demonstrate if there is a performance issue, is it with Komprise or is it with the environment or topology? And by leveraging ACE and the application that runs behind the scenes, it's actually run separate from Komprise. So we can kind of create that the divide to understand what is the source of the issue. And based on the results set, we can actually provide some indications or help the customer understand where that issue might lie. So different timings, different response times, different patterns that we see in the results set will kind of help guide. Is it potentially a firewall issue? Is it an antivirus issue? Is it an interface on the network that might be it might be intermittent? Is it an asymmetric route? Is there high latency? Because we're going to test both read and write from source and target. Yeah, great question.
And I think harking back to your original diagram with all the toll booths and the yield signs, Komprise has to ride along the same highway, right? We don't have any other path to get from local NAS A to local NAS B. Whatever is in the environment, we're leveraging it, correct?
Correct. Yes. I mean, so all data has to go over the network, and everyone is subject to it. And when you start seeing, like I referred to earlier, there's cracks and fissures, is when you start sending data in volumes. A lot of times you can move a couple files, move one share, not see any issues. But when you start moving data in a much larger format, is when you start noticing these toll booths along the way. And that's when it makes sense to work with your peers, your other internal departments, if they're separated from the team you're in. Definitely partner with them up front. No, is there a way to bypass it? Is there a way to cable differently temporarily? Or are you required to go through all of these systems? And if you are, again, what's the most efficient way through? Get in that express lane, leverage the 10 lane highway, but get in the express lane.
So Ben, in this diagram, just to make it concrete, when Komprise is installed, where does it appear in this diagram?
Sure, it's going to appear alongside your application servers. Absolutely.
Okay. Uh-huh.
Yep.
Thanks.
No worries. All right, I'll get back here. And Scott, I think it's back to you.
Okay. A few pointers. I think we had some of these up from the previous sessions. The quick start guide for analysis. I think most of you already have the deployed grid, so I think the analysis guide is one you might want to revisit it. Talking about the next session. So when we were putting this together, there was just so much to talk about that we decided to divide this into 2 sessions. So this session is going to be primarily focused, or was primarily focused, on NAS to NAS LAN type data movement. Next session, we're going to revisit this topic of performance, but we're going to focus more on WAN data movement, both from a migration standpoint and from a tiering standpoint. So, and then there's also the ACE engagement that Ben mentioned. How's that played in as well there. And I think those are the main topics we want to.
Hey, Scott, yeah. We do have a question that's come in.
Oh, okay.
Benjamin, question on the ACE tool and some of the best practices. Are those only relevant for some specific types of migrations? Are they generally applicable? Is it only for migrating up to the cloud?
Sure. Yeah. So ACE can be leveraged for on-prem to on-prem, on-prem to the cloud, tiering, archiving. We can test several different scenarios. They can be tested one at a time. So if you're planning on doing migrations first or migrations last, but tiering somewhere in that process, we can test all of those cycles for you and get the different result sets, so you can see what kind of performance you can expect on-prem, as well as leveraging your WAN into the cloud.
Very good. Thanks.
Okay, we're exactly at the bottom of the hour. However, myself, Paul, Ben, we don't have a hard stop. So if that concludes the content for this week's session. But if you have questions, we're happy to stick around. Also, we'd like your feedback. Is the content you're finding? I think a lot of you have been on most of these webinars. Is the content relevant? Is it going deep enough? Are they on topic? Anything you'd like to hear in future sessions? Please let us know. Just maybe stick a note in the question mark here, or send a note to your CSM. So we'll stick around for a few minutes. If you guys have questions, please sing out. And other than that, we're done for this session.
Seems like nothing else is coming in yet on the channel.
Yeah, you have to be a fast typer. Quiet crowd this week. No, we had a ton of questions the first session. None today. Well, one today. Okay, I'm not sure if the registration for the next session has been posted yet, but keep your eyes open. Again, go into the Fresh Desk homepage, the Fresh Desk Support Portal homepage. You'll see under announcements, you'll see links to the upcoming sessions. We'll have that there shortly, and there'll be some emails going out. And with that, we look forward to seeing you in a couple weeks. Okay.
Oh, quick question came in. Are these recorded and available to view somewhere?
Yes, they are. If you go to the registration site, the previous sessions have links to the recordings. And if you lost your placeholder of where the registration site is, you can always go to the Fresh Desk Support Portal, and under announcements is a pointer to the registration site where you'll find the recordings. Okay, I think that's it. Okay, we'll talk to you in a couple of weeks. Thank you.
Thank you all very much.